So after there, my lovely student, let us proceed with our discussion here, as we have been told, my lovely students. So after being said that for the maximum oscillation, for the maximum amplitude of oscillation, the value of x, they are supposed to to vary from a wavelength divided by 4, then 3 wavelengths divided by 4, 5 wavelengths are divided by 4. Then here we have been told that b is minimum and equals to 0. Let us imagine that this value of b will be a minimum pale ambapo atakuwa ni sawasawa na sifuri. Kwa huyu amplitude of oscillation could be equals to 0 if could be minimum if its value is equal to 0 kama tulivyoambiwa here. So the notes, kwa pale kwenye notes tunapojaribu kuobserve kwenye notes, huyu amplitude of oscillation atakuwa ni sifuri kwenye notes pale. Kwenye notes atakuwa ni sifuri, lakini kwenye antinode atakuwa ni maximum kwa sababu value yake itakuwa ni 2a, lakini hapa atakuwa ni minimum kwa sababu value yake itakuwa ni sawa atakuwa ni sawa na sifuri kwenye node. Hence equation number 20 here, equation number 20 for our 8 topic can be used to find the position of the nodes and also the antinode in the stationary waves. As we observe, my dear student, we have been told that the equation number 20 for our topic number 8, it can be used to identify, to find the position of the node. Kwa pale ndio utaweza kutambua kasa kwamba position ya node iko wapi na position ya antinode iko wapi, my dear student. Ndio kitu ambacho tutaweza kukiangalia pale kama tulivyoambiwa kwenye swali letu. So after there, let us proceed and see the example, another example here. Let us try to see the example related with what we try to discuss on our discussions. So we have our example number 4 for our topic number 8. Kwa tuna example number 4 for our example number 8 here as we observe. And our example say that, our example as you see here, my dear student, say that consider two identical plane. We have the two identical plane progressive wave and also traveling in a strain in opposite direction. We have the two identical plane. We have two identical plane progressive waves. This they are traveling in a strain in opposite direction. If the resulting wave is given by the equation, kama yule resulting wave atabini expressed by this equation, kwa kusema kuwa huyu displacement ni sawasawa na 8 times cosine 2x then we times by the sine 3t. Now determine the particles displacement of the two identical progressive waves. Anataka tuweze identify the particle of those two the particle displacement of the two identical progressive waves, kwamba tuna hizi wave mbili, identical wave mbili. Hizi identical wave mbili zina try to move in a strain, lakini ni opposite direction, kwamba nyingine ina move kuanzia kushuka chini, nyingine ina move kupanda juu kama tulivyoambiwa hapo, my lovely student. But the equation we have been given and we was asked him how can we identify the two equations, the two equations of the identical displacement. So first of all, we should use this formula. This, as we observe our formula, my dear student, we have been supposed to record the general formula there. The general formula that we demonstrated on the past discussions inayohusiana na stationary waves, ambayo inasema kuwa huyo displacement ni sawasawa na 2 amplitude times the cosine of kx times the sine of the wt. Kwa tutatumia ile equation kuweza kucompare hapa, kumake a comparison. If you compare, you should obtain the amplitude is equal to 2a, because here is 2a. 2a must be equal to 8. Now the amplitude must be equals to 4. Also this kx, we have for our formula, we have the kx. kx is equal to 2x. Now the wave motion must be equals to 2. And finally, a sine of the 3t. Let us attribute the wt must be equals to 3t. Kwa ukikompare pale wt is equal to 3t, utakuja utapata kumbe w is equal to 3, my lovely student. This is what we have been supposed to do in order to determine those two particles at displacement, two identical particles at displacement traveling in the opposite direction in a string. So after there, as we've seen here, we have been told to go for the equation number 18 as I started to summarize. Let us recall for the equation number 18, number 19 for the topic number 80, and make it a comparison. For you make it comparison, we should obtain that the amplitude must be equals to 4, and also the wave motion must be equals to 2, and finally the angular velocity must be equals to 3. Kwa hiyo tukimeki comparison hapo tutakuja kupata sasa kwamba the two identical progressive waves can be expressed. Sasa tutarudi zile equation zetu ambazo tulikuwa tunazitengeneza. Equation zipo mbili pale. Ya kwanza inasema kwamba yule particles anapokuwa anaenda right, their displacement must be equal to a sin bracket wt minus the kx, lakini w tunaye ni sasa na 3, and also that k is equal to 2. The amplitude is equal to 4. Kwa ukisha substitute pale utakuja utapata sasa kwenye first equation y1 the first displacement must be equals to 4 sin bracket 3t minus the 2x. Pia kwenye second the same, hapa tunaangalia particle alipokuwa na move kuelekea kushoto. Kwa alipokuwa na move kuelekea kushoto tutaona kasa kwamba the displacement along to the coordinate point x, t must be equals to a sin bracket the wt plus the kx, such that this y2 atakuwa ni sasa displacement we have which is equal to 4 sin bracket 3t then we add by the 2x. Kwa hizi ndio equation zetu mbili ambao tulipaswa tuweze kuziandika, my dear students. So after there, let us try to see another example here. Tujaribu kuangalia mfano mwingine hapa, my dear student, the example number 5 for our topic number 8. And our example said that the wave function for a standing wave in a string is given by this one. We have the wave motion in a standing or a stationary waves, which is expressed as displacement is equal to 0.3 sin of 0.25 at x times the cos of the 120 ni 120 pi t, where x is in meter and t is in second. Now we have been asked to determine the wavelength, the frequency, and also the wavelength, frequency, and the amplitude of the superposition waves. Tuna equation yetu hapa, tumeambiwa tuweze ku identify those two things. So what is we are supposed to do here, my lovely student? First of all, we should make the comparison. Kwa tutajaribu kufanya comparison, my dear student, and we should obtain that this wave motion is equal to 0.25, and also and also we should use this relation wave motion ambayo ni sawa na 0.25 tuliyopewa kwenye swali letu, lakini kwenye formula yake ni sawa na 2 pi divided by the wavelength. Kwa tutaweza kumpata pale huyu wavelength atakuwa ni ukicross multiplication atakuwa ni sawa na 25.13 meter. So after there, angular frequency w, huyu angular frequency w atakuwa ni sawa na 120 pi is equal to 120 pi, my dear students, which is equal to 2 pi f. Kwa atakuwa ni sawa na 120 pi, pia ni sawa na 2 pi f, my lovely student. And this could give us f is equal to 60 hertz as we observe here. So after there, we should if we substitute, we should obtain that this angular velocity is equal to 120 pi is equal to 2 pi f frequency. Tutaweza kumpata final, tutakuja kupata kwenye amplitude ni sasa 2a is equal to 0.3, and this give us amplitude is equal to 0.15 meter. Therefore, we could conclude by saying that the value of the wavelength is equal to 25.13 meter. The value of the frequency is equal to 60 hertz, and also the value of the amplitude is equal to 0.15 meter. This is what we have been asked to find on our equation. So by saying that, thank you for following our Educare Media, my dear student. Now I wish you all the best. Have a nice moment.